Okay, we get back to the language of calculus again. This is your tutor Wambinji. Okay, we look at further examples on differentiation. Okay, look at this example. So we have to be disciplined and understand the question in and out. So the question says, two variables x and y are related by the equation y is equal to 2x squared minus 3x. Okay, so this is just the equation that we are given that simply relates y and x. So the question says obtain an equation. Okay, obtain an equation for dy dx. Obtain an equation for dy dx and find the approximate change in y as x increases from 2 to 4. So in this question, class, we have to find two answers. The first answer that we have to find is just the dy dx of this equation. So we look at the solution. So we just bring this equation, we write down here. We say solution, we get this equation the way it is given in the question, we bring it here and say the dy dx, remember, is just found by simply looking at the power of the variable here. So the power is a 2. So we multiply this power 2 times this 2, you get a 4. And then you take away a 1 from this 2. So you're going to have a new power of 1 here. Remember, differentiation is just times and take 1 away. Times, take 1 away. Times, take 1 away. So 2 times 2 is a 4. Then this 2 minus 1, you have a new power of 1 here. And then you get this minus, you come here. The power of x here is a 1. Okay? So this 1 times the 3 is a 3. Then there is a power of 1 here. This 1 minus 1, you're going to have a 0. Okay? The power of x here will be 0. And remember to say, anything, this x will have a power of 0 here. And this x to the power 0 is 1. So this 3 now times 1 will remain with 3. So the dy dx of this equation, okay, is 4x minus 3. So we have answered the first part, which says obtain an equation for dy dx. Obtain an equation for dy dx. So we have answered that part. Okay, so we look at the second part of the question, which says, and find the approximate change in y as x increases from 2 to 4. So what we do is, using our dy dx, okay, or our gradient function. I said dy dx is also called the gradient function. So using this, so we are given the two values of x. The first value of x is 2 and the other value of x is 4. So see to it that this value of x is increasing from 2 to 4. So for us to get the approximate change in y as x increases from 2 to 4, we have to come here and say, what will be the value of the gradient? Okay, what will be the value of the dy dx when x is 2? So you get this equation for the dy dx, this 4x minus 3, that is the one I've brought here. So where there is x, you put a 2. So the operation that is between 4 and x is a times. So you get this 4, you bring it here. Then you get this 2, the value of x. Where there is x, you put this 2 here. Then minus, then you say 3. 4 times 2 is 8. 8 minus 3, you get a 5. So the value of this dy dx when x is 2 is 5. And this 5 is called the gradient of this curve. Okay? Of this curve at the point where x is 2. So the gradient is 5. So we are done. We have found the value of this dy dx when x is 2. Then we come here. Remember that the value of x is increasing from where? From 2 to 4. So what will be again the value of this dy dx when x is 4? So again, in your dy dx, where there is x, you put the value of x 4 here. So dy dx equals 4 times 4 minus 3. This 4 is coming from the fact that we have been given the 4 from the question. That's the 4 here. It is increasing from 2 to 4. So the value of this dy dx, when x is 2, we got it. It is here, which is fine. Then the value of this dy dx when x is now 4 will be what? 4 times 4, 16. Then 16 minus 3, you get what? You get 13. See that? So this 13, the meaning of 13 here, it means this 13 is our gradient. Because this dy dx, it is also called the gradient function. So this is our gradient function. So this 13 is a gradient and 5 is a gradient. You see that? Then you come here now. How do you write your answer now? You say, as a student of mathematics, we have understood the question. Now, how to write the answer? You write your answer as the way the question is asked. You say, therefore, the symbol for therefore, the change in y, when x increases from 2 to 4, okay, is 5 to 13 respectively. So we are done. Okay. Then we are done with this part. Thank you very much. Now we look at the last part. This part now is what we call differentiation again, but now we are looking at the quotient rule. It's a part of differentiation where you are given a question that has a numerator in form of an equation and the denominator again is an equation. So the meaning of quotient means division. So we can also call this as division rule. We look at examples. So the question says find the dy dx for the equations below. Look at the first this example A. You are given y equals x to the power 3 minus x plus 7 over x plus 2 minus 3. You've seen that you are dividing the equation divided by another equation. Now that look at this question, it's not as simple as those questions we've looked at where you just had a single function. You are dividing two functions, the function on top and the function at the bottom. Now that you are dividing these functions, we are calling this rule as a quotient rule. Quotient means division. So how do we differentiate such equations? So what you do is, we have to name these equations. The equation on top, we should give it a name, and the equation at the bottom, we should give it a name. So what we do is, when we are differentiating such equations, we start with the denominator always. We respect the denominator. Because the denominator is carrying this thing, it has weight. So we have to respect this part. So we always start with, we let v. It's just a name. We are just giving it a name. It has no name. We let v to be equal to x squared minus 3. You see this? We are just giving it a name. This denominator, x squared minus 3. We let this to be equal to v. So v equals x squared minus 3. And we let now the numerator, the function on top, to be equal to u. Why am I using v and u? I'm using v and u because I just enjoy these letters, v and u. I just enjoy them. But the truth is, we have to start with, we let the first function, we name the numerator first. I mean, we name the denominator first. The function at the bottom should be named first. Let this to be that, and let u to be that. U and v are just like these letters of the alphabet. That's it. Then from here, look at that. Look at these two equations. There is no y here. We are using v. So here we can't say dy dx. Now that we are using v, where there is dy, we are going to name this as dv. So this will be dv dx. We find the dv dx. We find the way v is going to change with respect to x. So dv dx equals 2 times 1. There's a 1 here, which is a 2. Then remove a 1 here. Times take 1. Times take 1. Differentiation. 2 times 1, 2x. Then minus. The dy dx of a number without a variable is always 0. So the dv dx is 2x. You come here. Again, we find the what? We find the du dx. Now that we're using u here, we can call this dy is du dx. So du dx is found by 3 times 1. It's 3. Then minus 1 here to be 3x squared. Then this x, there's a 1 here. 1 times x, okay? It's a 1. Then this 1 here minus 1, you're going to have x to the power 0, which is 1. 1 times 1, you get a 1. And then here, there's no letter. Just throw this away. Because the dy dx of this constant number is a 0. So the du dx is 3x squared minus 1. That's the first step. The second step now, we write the formula for dy dx now. So the formula for dy dx is, you always start with what? The name of the denominator, this v. You start with v times du dx. See that du dx is here. This is our du dx. So v times du dx minus. This minus is coming from the formula, okay? To say when you are carrying out this quotient with a rule, there is a minus here. If you want to know how this minus came about, remember to say when you are looking at indices, division, when you are dividing numbers of the same base, you subtract. Okay. Then you say minus u. U now, you say minus the u, this u, the function on top, times dv dx, where your dv dx is this, over your denominator squared, where your denominator is a v, this v squared. Then from here now, we substitute. What is v? You come here. Your v is here. So you get this v and put it where there is v. That's the one I've put here. Okay? Then you open these brackets. Du dx. Where is your du dx? Your du dx is here. You get this du dx and substitute it where there is du dx here. That's the function I've put here. Then you get this minus, you bring it here. Then you come here. What is your u? Your u is here. You see that? You get this. You get this u and substitute it where there is u. That's the one I've written here. Then you open these brackets. dv dx. Where is your dv dx? Your dv dx is here. So you get the dv dx here. You put it here. Okay? I'm just doing what? I'm just substituting here. Where there is v, you come. Where is my v? My v is here. You put the v there. Where there is du dx, where is your du dx? Your du dx is here. You put your du dx here. You get the minus, bring it here. Where is your u? Your u is here. You get your u, put it there. Where is your dv dx? Your dv dx is here. You get your dv dx, put it there. And then you get this division line. You bring it here. Over v squared. Where is your v? Your v is here. Get your v, x squared minus 3. Then you square this. There's a square here in the formula. Put a square here. Then from here we expand now. We just multiply this times that. You know how to expand this. This times that, you get this. This part. Okay? Up to here. You see that? Okay, and then you get this minus, you bring it here. Then 2x times x to the power 3, 2x to the power 4, 2x times negative x, you get negative 2x squared, 2x times 7, you get positive 14x, you close. Okay, now that you have a minus here, you remove this minus by simply doing what? You say negative times positive 2x to the power 4, you get negative. Negative times negative, you get positive. Negative times positive, you get negative. And then from here, you bring down this, you bring it here. You see that? Then from here now, what do we do next? We just group the like terms together. We have a power 4 here and a power 4 here. 3x to the power 4 minus 2x to the power 4. You get x to the power 4. See that? Negative x squared minus 6x squared is negative 7x squared. Negative 7x squared plus 2x squared, you get negative 5x squared. Then you say minus 14x plus 3. All these four terms here, you can't simplify any further because these are all different terms. Then over this x squared minus 3 to the power 2. So this is our dy dx now. We are done. Okay, that is our dy dx. We don't have to expand this. We just leave it like the way it is here. So this is your dy dx. So thank you very much for this. So go through this work again. If you have questions, you can still catch me on my WhatsApp line, okay? On my WhatsApp line, ask me questions. You can simply WhatsApp me on 978 95 44 99. That's my WhatsApp number. Ask me questions for further explanations. Thank you very much.